our last lecture of the day. Okay, so today Christos Karystinos will tell us more about water management regenerative approach for farming. I will just introduce him a bit. Christos Karystinos was born in the island of Zlarin in the middle of Greece and graduated as an electric engineer in National Technical University of Athens. His fields of work vary from appropriate technology, social permaculture, permaculture education, and permaculture design. He has experience in the research and implementation of appropriate technologies for Mediterranean climates like PV, solars, and hybrid autonomous systems, solar cooking, and solar drying. Thank you, Christos. The floor is yours.
Thank you. Thank you, Maria. Thank you for having me here. So, Maria forgot to tell that I'm also a farmer. So I'm cultivating olives and herbs, and that will be the project, my future products. So we're going to talk about water management. I am, as I told, very much connected with farming, so I will look this from this perspective and through the perspective of permaculture, which is a holistic design about how humans can live in harmony with natural ecosystems and that they both benefit from it. Water management is just not about water. So what I said is going to be different from the previous presentations is that water is connected with soil, is connected with fertility, water is connected with the fires, because if you have humidity in the soil you don't have the risk of fires. Water is connected with everything around us, from the food to how our buildings are made. So it's something that really connects everything. Okay. So the people already knew how to treat water. We just forgot how to do it, and now we're just redesigning, getting back to the traditional knowledge that already existed. So I'm gonna first demonstrate where I'm getting my resources from, where I am inspired, and where I'm basing my scientific data and the practices I'm bringing in. So the literature I am bringing in is by an Australian permaculturist, Yeoman, which with his key line design. Key line is the line in the landscape that is the line that we want to intervene and work with this line to catch the most water we can on the landscape. Is the one who really initiated big movement on the water management in the whole world. Then one of his followers, Mark Shepard, with his book Water for Any Farm. Then Brad Lancaster with rainwater harvesting for drylands and beyond. I'm mainly going to be talking about techniques about drylands. I am coming from one of the driest places of Europe, from Crete, right now. We have pretty much the same millimeters as you have here, 650 to 700. Actually, I think my village where I live have almost the same that you have here. So it's a very similar landscape I'm working on, and depending on the soil and the conditions of how humans have treated it, either have more vegetation or not. But the climatic things I'm seeing back home is kind of the same that I see here. So this book of Brad Lancaster is amazing for small earthworks about water management, and then it's the Bible of permaculture by Bill Mollison and David Holden with the permaculture design manual, which gives the whole concept of permaculture and the holisticity of all of it. And then I'm referring to some people which I'm bringing in concrete examples of how to do things. Okay, so one is in Italy, was my first permaculture teacher, Giuseppe Sanicandro, is in Puglia, just the other side of the Adriatic from here, and he's also working in a very dryland conditions. That's in the middle of Greece. That's Christos Karystinos. That's in Crete as well, Nicholas Vespolakis, with his, I'm going to be talking also about his field, his permaculture field, free field. And this is where I was living in Spain and working also in a very arid environment with less than 500 millimeters of water. Sunset Desert Technology, it was a research center about water management, dryland restoration, etc. So I have all these kind of references. They are all Mediterranean references, from Spain to Italy to Greece, and we all face the same problems in terms of scarcity of water, actually. So my personal project is based on permaculture, and there's three basic ethics that all the work that I'm doing and all the work that I'm teaching is based on. Is the care for the earth. We've realized that we are going through serious climate chaos and serious environmental problems, and we need to do something about that, so there's an urgency on doing something about that. And instead of just talking about sustainability, we really want to regenerate the ecosystems. That's the idea of permaculture, that's what I'm bringing in, not just sustaining the resources we're using from it. And but at the same time, we need to take care of the people and how we organize ourselves and what kind of tools we use in order to communicate with each other, and at the same time how we're going to be sharing the resources that we have in the present moment fairly between us and the future generations. So this is the basic, let's say, philosophy of all the work that I'm going to present, but also the work that, if you hear permaculture around, that's the basic philosophy of it. What I'm doing back in Greece, but generally also in Europe, that I'm designing land for other people. I'm teaching permaculture courses and permaculture design courses. I just came back from Italy in one, and then in Greece we're organizing with different organizations. I'm consulting farmers or other people who have projects about their farms, and as I said, again, I am a farmer myself. In Crete, in the west part, which is kind of the wettest part of Crete, and then I'm also a founding member of an NGO called Evolving Cycles, which is, let's say, the Greek network of permaculture projects in Greece. So we are at the moment we're 3 and growing, and then we're trying to connect each other and help each other in funding, resources, knowledge, etc., etc. And yeah, I'm calling it Community Lab because the vision is that through the regeneration of the land, the community around this land can be regenerated. So it's my core belief, and as through my experience, that if there is a land that is regenerated and has enough food and enough resources to sustain people living around it, then the community, the people, will start gathering and start getting together around this land. And that's the example of what's going on right now in the village that I'm living in. Someone started there, regenerated the land they're living in, produced huge amounts of food that not only for him but also for selling and for other people, and shared it in such a way that more and more people came and just started also creating community around this farm. So let's talk about water. So I'm gonna be simplistic. I'm gonna be simple but not simplistic. I'm gonna do it the way I'm doing it in the courses, talking about something like the people listening to it know nothing about it. Okay. So the water flows from the top to the bottom. Okay? We agree on that? Yes? Okay. So the second, let's say, basic principle is that the landscape is curved in bigger water flows as it goes lower. So you will see the streams, so they are smaller, and then once they go down, they open up in deltas and they become. Why is that? Because more and more water is gathered inside, and so it needs more space to flow towards the sea. And then the third one is that there is not only one water flow, there is 2 water flows. There is one on top, the one we see, and then there is one underneath. So always when you see, for example, a dry river, do you see a water flow over there? Most of the times there is a water flow, but we don't see it. Where there is the watershed, probably there is an aquifer down. Maybe it's not the case here because it's a very karstic geology and the water just goes and goes away. But in other types of geology, where there is dry rivers, most of the cases you can really imagine that there is an underwater, there's an under the soil flow that when this aquifer meets the soil in altitude, it becomes a spring. So you have a river again. So that's the basic things to really get an understanding of what we're talking about. Have you ever heard of contour maps? This kind of maps, which have contours, you know, like hiking. Okay, that's very basic in order to understand a landscape, to read the landscape. When if somebody's gonna tell you, there's this and that and this, so you can just ask for a contour map and then you can understand where there is peaks, how high is this, what kind of valleys there is there, what kind of ridges. So in order to get more concrete and understand them, these are not just hiking maps because they also can really refer to also farms. So here you can see, so if that was inclinated like that, you can see that this is the line where all the points are on the same altitude. Okay? It's not straight lines. In nature, most of the times there are no straight lines. We are creating straight lines because we like it this way. But in nature, most of the times there are curved lines. This is an example from a farm I worked on. So with a very simple tool, an A-frame, if you would like to, I can explain afterwards what it is. You can really find the contour line on a farm. And what I did here is just I dug a trench so for the water because there will be a lot of erosion. So I dug a trench where this will cut all the topsoil and all the water coming in, fill it up with organic material, and then wait for the rain. So you can see, like, because it's pretty clear landscape, you can see the contour line very clearly here. No? Okay. Okay. Let's talk more about water. So the water always flows from the easiest to the easiest way down to the sea. So if we have a contour map, and if you want to calculate, okay, I see something on the map where the water will go, you just take a straight line to the sea, and that's where it goes. Okay, it goes vertical to this. Okay? It forms what I said before, ridges and valleys. Ridges, do we know the word ridges? Yeah. So if it goes like that, that's the ridge, and that's the valley inside. Okay? Valleys leads to less steep valleys until delta of rivers. And what is an aquifer? The aquifer is an underground river that also follows the same flow down to the sea. Where it meets the surface, there is a spring. Water moves upwards and downwards according to the soil. Okay? Capillarity. Okay, so what's the natural pattern of water? In permaculture, what we try to do in order to design whatever is trying to mimic natural ecosystems. So as we say always, forest is our teacher, let's say, but in this case, the natural rivers, the very few remaining, at least in Europe, are our teachers. What is the pattern that the natural river follows? It's a snake. Why is a snake? Because in this way, the water can really slow down and leave all the sediment that it's bringing in. Okay? Because if you make a straight line, what we do right now, humans, and I don't know, but it's very common in Crete at least, is that they make straight lines, they put these cubes around next to the banks of the river, and then the water just flows rapidly towards the sea. And when it meets a city, you have a flood. When it meets a settlement, you can just take the settlement and go away. So here we can see, let's say, one of the basic. So there's few problems with how we manage water right now. This is one of the major ones, that we change actually the landscape in something that is comfortable for us, but is totally counter logic of how the water should flow in a natural way. So it's about velocity and erosion. When water goes faster, it can create more erosion, and this will create more erosion because there is no plants, and it's a loop that leads totally to destruction. So it's not only in climate crisis that we're facing right now, we're not only facing that we're getting more millimeters of rain per hour at one instance, but we are also having more eroded soil that accepts this kind of millimeters. So we have a loop of problem that is being reproduced the whole time. So let's go to solutions, because that's what we want to work on. So what I call the 4S is the slow, spread, store and soak. And this is what I'm going to be talking about in this presentation. So, slow down the water before it leaves from your landscape. And this is where I'm talking about somebody who reads their own landscape, like if it's a farm or if it's a town or if it's where I'm working on. Spread the water. Spread the water in your landscape from the valleys to the ridges, which means from the most humid to the most dry spots. So, what they were doing with the canals is that they were driving away to a place that it was probably very humid to somewhere that was not as humid as that, as the other place. Store the water. Store water in your landscape. Create microclimates and use when you need it. So here I'm talking about mainly either cisterns, the ones we were cleaning today, or natural ponds, or dams that are filled in when there is water, and maybe they stay or they don't stay depending on the kind of soil and where there's the aquifer. And soak the water into the soil, create the best water storage available, which is topsoil. So I don't know if you know it, but the best technique we have in order to store water and not let it go to the sea is this black soil we were touching today, which is an amazing sponge. So this topsoil that I'm talking about, this black soil, it can really hold amazing amount of water in its volume. It's like it has holes inside, and then it absorbs water and can really hold it also in the long term. So if you have this kind of soil, either in your farm or either in your lands or in your forests or wherever you want it, if you want it on the mountain, then you go there and then create as much topsoil as you need. So this stops erosion, holds the water, creates vegetation. It's like solution for almost all the problems we have as humans in management of resources. Because it's not only like stopping of having problems like floods, but it also creates positive problems, which you have, for example, trees that you can just cut and then take wood out of. You know, this is the way of mentality of working on regeneration, not just sustainability. So let's go more practical. How to slow down water. The previous presenters were talking about microdams. Here in let's say the international more terminology, we call it check dams, because they can be different. They can be with different materials. Actually, you use the materials you have there on spot. You have trees, you use branches. You have bamboo. You use bamboo. You have rocks. You use rocks. The idea is to follow in your landscape where there is erosion, and this you can really see by either taking a topographical map if you want to really see in the bigger image, but if you go there and walk, you really see the paths of the water. Most of the time it's visual by eye, and this is where you want to stop water. Because what water does, and very smartly does, is when there is a path, it wants to create deeper and deeper and deeper and deeper and create actually a river. So that's the natural pattern. You know, probably there was somewhere a river, we came in there, and then it starts creating one. So this is an erosion channel, what we call, because if there's no vegetation, it just creates more and more erosion. So what we want to do is go there and create dams in order to stop this. So the dams stop the sediment slow down the water, create the roots can really go there and absorb the water, and that's what's happening also with today. So the roots and the plants stop the water from entering inside the cistern. That was the natural way of doing it. So that's one thing to slow down water. Other thing is rock dams. So rock dams doesn't have to be either as high as Buluki guys were mentioning. Rock dams can be really even on 1 or 2 rocks high dams. Rock dams you again go where you think that the most erosion is there, and then you place them in a way that if they will catch the topsoil and the sediment, and you have the same function. And very important is the access. So access, like paths and roads, are like what we call dead surfaces. So they have a big factor of not absorbing water, because we want them this way. That's what roads and paths are. They are dead surfaces which we don't want plants to grow on them. So if no plants are growing on them, there is big runoff, what we call. So in these places, it's very important to cut this water because it's a big channel of erosion. Big channels of erosion are streets, because they are paved, so the water doesn't enter in, but at some point it accumulates and then it goes somewhere. Most of the times where it goes, it creates problems. So what did we invent to do? We create channels and then we quickly drive it to the sea. So there is no water infiltrating inside the landscape. One of the ideas, and one of the ideas that really is bringing a change also in the way we are designing these water systems along the big highways, etc., is that you actually cut this water, and then once it goes out of this paved road, you create. Let me show. Okay. For example, that's a road. While it goes out, it goes inside a rock path. It goes like multiple rock dams, which slows down the water, catches the sediment, and then it actually waters things. So that is actually one thing that you can, if your farm is next, or whatever, is next to the road, you can use this free water source by diverting somehow this water into your farm, but slowing it down, because if you just bring it in, you're just going to create erosion. Another example of how rocks, how this thing can really slow down water is this is another trench, like the other one I was showing you, and this is the overflow. Again, it's very basic. Water management is very simple and very basic, according to my understanding. This is again an overflow. So when this is filled, the water goes here. The same thing here. This is a trench. I cut the water. When the trench is overflowed, I put some rocks in order to slow down and not create erosion. Overflows with rocks. I talked about that. Low. Okay. Yeah. So in the landscape, you can create this kind of dams in order to to slow down the water. Okay, spread the water. This is a topographical map of a landscape, of a farm. This is the contour lines I was talking about. Most of the times, if you see a small piece of land, you're not going to see the full circles as we were seeing. Oops, sorry. Bye. Hello.
Yes, you close it.
I closed it.
Yes, yes, somehow.
There's a magical button of closing it. Okay. Let me see if now it works. Okay. So yeah, that's the, let's say, the more utopian landscape you will be working on. Never you will take to manage this kind of a whole mountain or a whole island. Probably what you will find yourselves in front of to handle. Okay, yeah, it's something like that. So the contour lines are this. If you continue, they will make a circle around the island. So here it's the main water flow. Okay? What I want to do is here, so here is my valley in my landscape. How I understand that? Well, if I take out this blue line, you will see that the contour lines are curved here. So I know that most of the water will be entering here. What I want to do, this is my most humid part. Anyway, I can't do something about that. Okay? I can either bring a bulldozer here and bring down the mountain, but I don't want to do that. So what I want to do, because I want to be energy efficient, is to, when the water comes in, to create trenches, okay, to bring this water that anyway is flowing here from the valley to the ridge, from the most humid to the most arid. So these are diversion channels, are trenches with or without berms. Berms are, if I dig a trench and then I put the soil on the other side, this is a berm. Okay? With or without it works, just putting it also it's more safe. That are inclinated no more than 3%. Like how do I measure the percentage of inclination? Can just take this, architect here can tell us. How do I calculate the inclination?
With what?
With what? With a measurement tape, let's say. I don't know, no, with a digital tool.
But the digital tool just tells you.
And if it's a digital tool, it's broken. How do we measure inclination?
1 meter, how, before 1 meter?
Yes,
how much
okay,
is,
so if this is my landscape, how much is this distance, how much is this distance, I can divide it and have an inclination. So if it's more than 3%, then that's a general rule, it creates erosion. Okay, so I want to dig these trenches, not make them too steep, because they are going to create erosion, that's not something that I want. And to take it from a higher point to a lower point. And then I create this trench, and voila, it's self-irrigating system. I'm taking the water when it falls and driving it to where I want it. Boom. They're used for moving water away from foundation of houses, from valleys to ridges. There's more cases, but here I'm saying more the simple ones that I was thinking when I put this presentation. So, how to soak water? Soak? No, it comes inside. Okay. In this case, it really depends on the type of soil. So there is 2 to 3 different, let's say, main categories of soil in terms of structure. The clay soil, the sandy soil, the clay sandy, sandy's clay, you can really find different percentages there. When it's clay, water comes in, but really it doesn't go away fast. When it's sand, it just goes away. What is the type of soil here mainly?
Sandy, in the terms of sand and clay.
Okay.
Not much.
Okay, it's very easy to test it. It's very easy. We do it with kids, and I think so everybody can really do it. You take a jar. You take a jar with 1 liter, let's say. You put 1/3 of the soil, whatever soil, and then you move it You don't drink it. You just leave it. You leave it on the table, and then one day after you go there and you see. On the bottom there is rocks and sand. On the top there is clay. And if you take a measurement tape, you can see how much percentage of clay and sand is there. And you can really see the difference. So that's a very scientific, believe me, it's a very scientific way. Don't laugh, this is, you can really make a very good, actually the results are pretty accurate. I'll tell you, I have made a soil sample analysis in a lab, and I made this at home. Let's say 1 to 5% of difference, which for deciding what kind of soil I have is very good. So in this way you can really know what kind of soil you have around you, because it's very important for what kind of plants you can plant, of how the water is falling on the ground and what it does, and just understand what's going on around you, really. And if you have clay, and it's very good clay, then you can actually start to do pottery also. You can experiment. So how you soak water inside your soil really depends on the type of soil you have. The idea is to plant where the water is already there. If you start from, most of the cases we start from a distracted environment, eroded, whatever. So where you have already water, you start in order to create some kind of niches, some kind of regenerated parts inside your landscape. So the roots are a mechanism for water to enter degraded soils, and the main idea to how to soak water is to stop them on contour. Why we want to stop them on contour? Because when the water comes and all the levels, all the points of this trench is on level, is on the same altitude, so the water is gonna, if this is the trench, the water is gonna enter inside. It's gonna fill up equally. Okay, so you're gonna cut with the energy you put to dig this trench, the maximum amount of water it's gonna be entering in the rain. Okay, and then you have an overflow, and it goes away, and it goes to the next one, and the next one, and the next one. That's why you want to work on contour. Generally, if you ask very crazy nerd permaculturists, they're gonna say to you, walk on contour, if you can, because that's the only way you're also not gonna create erosion, in a way that you also plant your plants on contour, you create your roads on contour as much as possible. If you're working on ecosystems that are very about to be erosive, then the best way you can do is to design your way into them on contours. Okay, both for water management, both for access, for planting, for all these that are connected. So, the very Australian term we're using for trenches on contour are swales, and now you're gonna see Maya being very happy on doing a swale. You can see how satisfactory it is, because here Maya is very it's 40 degrees in Crete, I can't believe I'm digging a trench, but look how happy he is after she finished it. Okay, yeah, but this is also a good example of how to use, what the swale means. We do have, this is a terrace, but it's a terrace that I want to create raised beds to cultivate, to put a garden on. And it's not leveled, because by the years the dry stone walls have fallen, so soil is coming in, and then it has been kind of almost not terrace. Okay? And instead of bringing in a bulldozer and making it flat again, which was an option, but it would be kind of energy and money kind of expensive, we try to, even in a terrace that supposedly is working as a water retention technique, to create a second safety, which is to create a swale. So what we do is that we mark the contour with pegs, and then we're bringing soil from here, there, creating a berm, and then putting a ground cover. In this case it was a sawdust, and then we sow. We sow things that really can create a ground cover on top of this trench. And this, if it works well, it stays there forever, and it works forever. So you do it once, and then you retain water for a lifetime. Other techniques of how to soak water is infiltration basins. So there are your trees. So you create basins so that when it rains, the water comes in, fills up, waters the plant, goes to the next one, waters the next one, etc., etc. The other one called media lunas. This was very famous in Latin America. That's why I'm bringing the Spanish name. So you have again an inclinated landscape. These are your trees. So you create a trench here from the downer side of the tree, and then you cut the water that is coming down. And the overflow is going to the next one, to the next one, to the next one. No, this we saw it. Store water. Favorite. So, big water storages. I'm not going to talk about cisterns because also previous presentation have been talking about, and you can very easily calculate size of cisterns. You take the area that we're cleaning today. How many square meters is that? How many millimeters? You can find that on meteorological data of the area. How many of runoff I'm having? Probably, let's say I'm absorbing 70 to 80% in a very good surface. And then there you have it. You have the volume of the cistern you want. Voila. But dams or ponds are more difficult earthworks. And they are more specialized, and most of the times you need to ask people like the first presenter, a hydrologist, or somebody who really has good experience to tell you if you have good enough soil, where is the best point to put a dam or a pond, and if you should make it or not. So it's more complicated structures. Traditionally, people used to create artificial ponds and dams in order to store water above their settlements. There is this amazing story in Jordan, in the Petra UNESCO. Have you heard of it?
Yeah.
Yeah. So they had a whole amazing system of how they were storing water, and because they were in the desert, in order to give water to their cultivars. So the basic, let's say, two factors of deciding about the dam or a pond is the permeability. If they're going to be permanent or temporary, what kind of material you're going to be using for the lining. If you're going to be using plastic and then you just forget about it, but you have the ecological footprint, or you're going to use natural material and check for leakages, etc., etc. It's a more complicated story. And then if it's appropriate to put this there, because these are things that are under regulation and they should be designed properly. If you have clay on site or not, this is an indication of you should go or not about that. Never put it on top of a house because then you have problems of flood, and many other factors that you should take into consideration. But generally, dams and ponds are, how to say, all these fancy words we were listening before, like niches of biodiversity and multiple functions and whatever. I mean, in the end of life, in the end of the story, they are sources of life. And I'm going to show you a specific picture because this is the field that I was talking about, the free field of my friend Nicolas. This was the driest place of his farm. It was shit, seriously. It was that you would cry if you go there because you would see dead soil and dead trees. actually. So just by the intervention of one, you enter inside and then create the pond, very carefully designed with the material that is needed, where it's going to go what, you can create this kind of thing. And this is in the same place that you will see pictures of eroded landscape in Crete, is in the same place. Just by making the right intervention into the landscape, you can create this source of life, which attracts all kinds of wildlife, from turtles, dragonflies, water snakes, frogs, and we're not talking about something Natura 2000 here, we're talking about 20 square meters. But if you multiply 20 square meters per 1,000 of people who can do that in their land, you have a little paradise in all over the place. So I know that specific places have specific importance, which are big natural reserves, and we should take care of them. But at the same time, we should see the landscape around us as possible also Natura 2000 and natural reserves. Because this is how they used to be. They used to be wild forests once, before humans cut down the forest in order to cultivate. And the idea is to create edible forests. By the knowledge we have right now, you can have the effect of the forest and at the same time to eat you and the wildlife around you. Okay, and then finishing up, in general, the concept of holistic design of water management is, through the permaculture perspective, about designing earthworks for multiple functionality, to combine agriculture with water management, what I was saying before, design according to the needs of the users. We do not design just by our own imagination and our crazy dreams, but depending on, this is also taking the social aspect very much into being, how to say, the center of attention of what we are doing with natural ecosystems. Who is going to be using it? If we're talking about Zlarin, really taking down the needs of people living here and seeing who is going to be using this type of landscape. This is the important thing. And monitoring, accepting feedback and adapting our design according to what actually happens. If we're going to be looking into the keyline system design, put water earthworks high in the scale of permanence in the landscape. The scale of permanence is how things can be easily changed. Water is one of the things that you can very hard change once you do it in a landscape. We can very hardly change where our rivers are at this time, and we don't want to change it. If we do change it, we need to be very careful on where we're putting our energy there. To farm the water, and that the water brings fertility, to find the key line, the line I was talking about, and use it as your line of everything in the landscape. You walk inside, you walk in contours, as I was talking about. And the master line system design, which Mark Shepard was introducing, it's an upgraded key line design to more edgy landscapes. So if you want, if the landscape you're going to be studying is not as flat as Australian one, Mark Shepard did really good adaptations and has a very good field manual on how to do earthworks, what kind of inclinations, what kind of machines you should use, etc., etc. So, that's it. Okay, I'm gonna stay with this because I think I'm gonna stay with this. So, now real questions. Like now you have questions and you can make questions. They can be more live.
Sorry, and the pond, you made the pond?
No, my friend made the pond.
And
yes.
It's lined with clay in the inside.
It's not a land with clay, and that's the very interesting one. It's a land with sand. And what happened is, so there was this interesting phenomenon that water was coming in, so he tried different ways of sealing the pond, but no plastic. He didn't want any plastic. So he brought in animals. You know, in the past they used to bring animals. The animals used to shit a lot in this hole, and then with this organic material, which is the shit of the animals, this created the plaster for the pond. This is a very old technique. It didn't work. Too sandy for this. So he gave up, kind of. So the water was coming in, and because there was the shit of the animals, it was creating algae. Okay. So in the summer, the water was going down because there was no constant flow. There was not this was not a pond. So the algae was remaining. So he was taking the algae and putting it on the sides and saying, I don't want it to be so algae, so lots of algae. Next year, the water was coming and it was filling more up. You say, oh, what's going on here? It was going down, taking the algae, putting it aside. So the algae created the impermeable plaster, which was self-created. You know, it didn't put anything in. The algae comes in when you have stationary water. You were gonna have algae. Okay. So the algae itself created this impermeable layer that created the pond.
But you can do it with clay also. If it's a clay land,
of course.
You can
if you have clay land, that's the land to do a pond.
We don't have animals.
Except from
well.
Yeah, I mean, you can import. The thing with ponds are dams actually. I mean, this is the same thing. So there is an upper part and a down part. In the down part, you need to make this cut the land and create this wall, earth wall, with clay. And that's the most crucial part of a dam and a pond. That's where you want to seal it as good as possible and have the higher quality of clay there and compact it. So you create a wall of clay, and then with appropriate inclination from one side and the other side, and with appropriate overflow, you have your pond with clay. Of course, this happened also here. There was the wall of clay was created. I'm talking about the permeability, which is another thing. Okay.
Aleppo pine foliage as sponge. Aleppo pine foliage as sponge. Do you like it?
Aleppo
pine.
Aleppo pine as
Aleppo pine foliage. The compost.
Yes.
As sponge. This is maybe.
Yeah. Today we were taking out the pine needles, and it was an amazing sponge because actually there was fungi there.
Yeah.
That created mushrooms.
Yeah.
There on top of cement, and now we're talking about on top of cement.
Right.
So if that can be done on top of cement, for sure it can be done on top of soil.
So there's quite a lot of it on one side of the island here. You think maybe moving this to another location, it's also a little acid. But I understand that the older foliage, the older compost, it breaks down the acid.
The thing with acidity and alkalinity, it's quite, how to say, people are scared about that, and the amount of really giving a fuck about that is really tiny. You know how they say don't make compost out of orange peels, you know?
Yeah.
Everything becomes compost. In the end of the story, we are gonna become compost. Are we too acid or too alkaline? You know, like the thing is, yes, create compost as much as you can from whatever you can. The thing is of having compost to use it for what you want to use it. If it's what you have is needles, how do you say?
Pine foliage, needles,
This pine needles.
100 years worth of it, about.
Yeah, that's amazing. If it has a bit of more acidity than you need, well, there is solutions. I need specific measurement of how acid it is. Then a bit of marble dust make it more, more alkaline, and then you fix it. But the interventions you need to make is very tiny compared to the benefits you have. Because the benefits of organic matter, which is this topsoil that you see this black, is much more than the acidity that you have. And then in the end, you are the one who should adapt. Because you are on an island that has, let's say, I don't know, acidic soil. So that's what you have to work with. You know, you go for plants that like acidic soil. That's it.
I'm not aware that we have a lot of black soil, but we'd like to build it up. And I'm wondering about taking the taking the topsoil from the Aleppo pine area and moving it to other areas where we'd like to use it as a sponge.
Well, in a very crucial time that you want to make something that will have a big impact, maybe do it. But the idea is not to take topsoil from forests and bring it into cultivars. The idea is to create topsoil. So how do you create topsoil? You plant plants that create a lot of biomass.
Yes.
And then you chop and drop them, chop and drop them, and you mimic the forest, and you create your organic material in your field. So if it's an olive cultivar, you plant stuff that create a lot of biomass, but you don't need the fruit. So you just can't, they grow a lot, acacias, eucalyptus, whatever, they grow a lot and then you chop all the time.
And leave it.
Or through a wood chipper. Yeah. And then in this way you kind of reproduce the way that a forest would go. And then you will have this black soil. And you create it. But if you want to make, let's say here, one specific line on a swale, and then you need compost, and instead of buying it from the other side of Croatia, yeah, go dig up a bit from the forest, from a place that it's okay to dig a bit, and then take it.
I think our swales are already dug for us for I don't know how many generations, maybe thousands of years. Ancestors have created the swale, the check dams. The whole island is a maze of very careful cultivation and maintaining the water management. So we have to work within a system that has been created almost already.
Okay. Amazing. Revitalization then.
Yeah.
If it already exists, is what we were doing today.
But if it's organized in a way that is community, like if the whole group, if I know my ancestors, the individual plots were trying to divert water into their plot rather than in their neighbors. I don't know if it's organized so that it's spreading out or makes a lot of sense, and then overall it would have to be analyzed. And then most of it on this side of the island is completely buried in Aleppo pine, which is a fire hazard. There's a lot of very interesting considerations here for permaculture.
Yeah, we also have Aleppo pine where I used to grow up, and it has been burning 2019 in the summer, 2020 in the summer, 2022 in the summer. The biggest of fires, and I just enter inside my phone right now and I'm saying again, fire in the south area. November. We are in November, guys. And yeah, that's the curse of having pine. You have amazing oak savannas. I was in the bus from Zagreb, passing down and seeing that in this side, in the coast, amazing oak savannas, amazing, and they have survived thousands of years. So yeah, they'll be looking to that as well.
Yeah, we have a couple on the island as well, so just a few, but before the pine it was mostly oak, black oak.
Yeah. It's more invasive. Yeah. But if the seeds are there and there is a type of management that really can, it's all about natural succession. Maybe there will be the conditions that if somehow the pines allow the seeds of oak to sprout, then this type of forest comes in. No, but it really depends on the, how to say, investigation, experimentation, maybe creating holes inside the forest, then check what kind of trees, natural vegetation is coming in, and experimenting with that because the seeds are on the ground already. You don't need to plant anything in most of the cases. Okay, what time is it, Ryan?
It's half past 9 has to pass.
9:30.
No, half past 8. Sorry.
Mistake.
8:35 to be precise.
Ah,
I
okay.
don't think we're gonna play the movie because everybody watched it.
Yes.
Ah, yes. Yes, we all did.
Does anybody have any more questions?
Comments, remarks.
Yeah. I just wanted to say that you don't need bulldozers if you have one. Grab a shovel and shovel the Zlarin over.
Maya can do work.
Okay, thank you,
Great,
Christos.
thank you.
Thank you.